Okay, welcome everyone to 3.4. We are going to talk about expanding our idea, right, from our indices, which have whole numbers, and we looked at 0 and then we expanded to negative numbers. We're going to push it one more step further and we're going to look at indices being a rational number. So what is a rational number? Rational number, it is a number that can be expressed as a fraction. Right, so now we will look at fractions in our index. Okay, so before we move on, let me show you quickly flash to you. These are some of our basic definitions and also our basic laws that we have, right? And today we're going to add on a little bit, maybe two more over here to show you what's really going on. Alright. Okay, alright, so over here we have two examples, right? I have a 64, I have a 512. Okay, so let us play with these numbers a little bit. Right, so when we talk about rationalizing, having index as a rational number, right? We are actually talking about square roots. Okay, so let us investigate what does the square root do. Okay, so when we have our 64, let us square root 64. And we all know that square rooting 64 means that we are getting, finding the number multiplying by itself. So 8 times 8 gives us 64. So square root of 64 gives us 8. But let us take a look at the power of our 2 in this case. So what is 64 over here? 64 is actually 2 to the power of 6, right? Yeah, 2 to the power of 6. Whereas 8 is going to be 2 to the power of 3. Okay, so the golden question is, right, if I were to take the square root, what is the number here, right, such that it will make my 6 become a 3? So 6 times what equals to 3? 6 times half is going to be equals to 3, right? So actually, like from the first example that we see here, right, square root, the action of the square root is halving the power. It means to multiply the power by half, right? Or we can actually say that, is 2 power 6 and the whole thing power half. So now we start to see fractions in our index. Okay, let us push this envelope a bit further and let's take a look at 512. Alright, so 512, I'm going to take the cube root of 512 and it's going to give me 8 as well. Okay, so but let's take a look at 512. 512 written as base 2, it is 2 to the power of 9. And 8 written as base 2 is 2 to the power of 3, right? So what is the power over here such that I will make this 9 to become a 3, right? What is the action of my cube root? And the action of my cube root is to make the index multiply by 1/3, right? So technically speaking, the action of the cube root means the power is 1/3. Okay, so we can do this again and again and again, and we've come to two more new definitions for this case, right? Alright, so the first new definition that we will see is that a, when raised to the power of 1 over n, right, like what we see in this example above, it actually means the nth root of the number. Okay, it means the nth root of the number. Okay, and at the same time, right, let's say if now I have a to the power of m over n. So what does this mean over here? I'm going to draw this two ways, right? Because m over n, you can write it as 1 over n times m, or you can write it as m times 1 over n. The multiplication, we call this commutable. We can swap places with this. So what do we have over here is a to the power of 1 over n. We've seen this just now, and this is equals to the nth root of a, right? And the whole thing power m. The one below is actually a to the power of m inside, and the whole thing will take the nth root. So what we are doing here is these two things are equivalent when we talk about a to the power of m over n. So this means that we have the nth root of a power m, or we have the nth root of a and whole thing raised to the power of m. Right, so we have two different interpretations, or two different new definitions that we can play with for our laws of indices. So without further ado, right, let us take a look at the practice now 9 over here, right? Okay, and this is in page 68. Okay. Alright, let's take a look at number A. We have 2, 5, 6 and to the 4th root. Okay, 2, 5, 6. Now, we can do this in two ways. We can split 2, 5, 6 to 4 numbers and we get the raw number. Or we can write 2, 5, 6 as a base of other numbers. We can write this as a base of 2. We can write it as a base of 4. So for this case, I'm going to go with the base of 2. Right, so 2, 5, 6 is equals to 2 to the power of, okay, so let us count here. We have to be familiar with our power. So we have 2, 4, 8, 16, 32, 64, 1, 2, 8, 2, 5, 6. So 2 to the power of 8 will give me 2, 5, 6, right? And the 4th root means that we are the whole thing, let me recolor this, right? And when the 4th root means that we take the whole thing, power 1 over 4, 4th root. So what does this equals to? 8 times 1/4 would give me 2. So 2 square is equals to 4. And we can double check with our calculator, right? The 4th root of 256 should give us 4 as well, alright? Okay, part B. So let me shift this thing here. Okay, alright, part B. We have 1024, right, to the 5th root. And without further ado, we need to see what is the power of 1024. How do we write this as index form? So we have 2, 4, 8 is an even number, so I'm guessing it will be more a multiply of 2. So 2, 4, 8, 16, 32, 64, 1, 2, 8, 2, 5, 6, 5, 1, 5, 2, 5, 6, 5, 1, 2, and 1024. So this is 2 to the power of 10. And to the 5th root means that I'm taking to the power of 1 over 5. And 10 times 1 over 5 would be 2. So 2 square is also equals to 4. Right, so we can test this. 1024. We can test this with the calculator, and it also should give you 4. Alright, C. C, we have 64 over 125, right? Whole thing, we have a cube root over there. So what is 64? 64 can be written as 2 to the power of 6. 125 can be written as 5 to the power of 3. So this like knowing our bases and the powers of our bases, very important. So over here, cube root means the whole thing power 1/3. So over here, we can distribute the 1/3 into the fraction. So we will have something like 2 to the power of 2, 5 to the power of 1. So 2 square, so 4 over 5, 0.8. Okay, or if you're uncomfortable, I'm going to write here 4 over 5. Okay, so next one, we're going to look at last one for D. Right, for D, part D, we have 64, 7 to 9. Right, and then the whole thing, what root is this? The 6th root. Okay, so let us dissect a bit. 64 is to the power of 6. 7 to 9 should be 3 to the power of 6 as well. Let me double check. 3 times 3 times 3, 27, 81. 81 times 3 would be 243 times 3, 7 to 9. So just nice. And the 6th root means that we're taking power 1 over 6. So this will leave us with powers of 2 over 3. Mainly just like that. Okay, next, let's take a look now at practice now 10 at the next page, and we continue to evaluate some of these figures over here. So 36 half, right? 36 to the power of half, we can recognize that 36 is actually 6 square. Alright, we just write 36 as 6 square, and 6 square to the power of half is just 6. Next, we have 625 to the power of a quarter. We need to know that 625 is the 5 to the power of 4, right? And the whole thing, we keep the power there, so this would be equals to 5. Next one, 243 to the power of negative 1 over 5. So first, I will need to write 243 as 3 to the power of 5. So you need to be familiar with this. Power negative 1 over 5. So let me settle the 1 over 5 first. So over here, I should have a 3 to the power of negative 1. And this means it's 1 over 3. Alright, last but not least for D, I have 1000 over there, and it's negative 1000 to the power of negative 1/3. Okay, so let's take a look at the 1/3 first. So this one I have negative 10 cubed, right, to the power of negative 1/3. So this would be negative 10, this would be negative 10 okay, this would be negative of 10 to the power of negative 1. So what does this mean? Would be negative 1 over 10, right? So this is for A to D. So the skills that we've looking so far is we need to evaluate certain values, right? Okay, so before we proceed, right, we have one more thing to examine. So over here, when we talk about roots, in order to play safe, we would usually say that A has to be a positive number, right? So especially for even powers, because there's no such thing as a square root of a negative number yet, right? So the condition that we can set over here would be in order for this to be real, A needs to be more than or equal to 0. Okay, same for this case. A needs to be more than or equals to 0. Even though you have negative powers that you can play with odd numbered like roots, but for even powers it's not true at all. Okay, so with this, let's look at practice now 11. Okay, practice now 11, and we're on page 70, if I'm not wrong. Yeah, we're on page 70. Alright, so with this, let's take a look at how do we evaluate each of these without calculator. So 1A, we have 64 to the power of 2/3. So 64, I can recognize this as a 2 to the power of 6. Then the whole thing, power 2/3. So when I were to multiply this, I would get 2 to the power of 4, which gives me 16. Right, B. We have a 32 to the power of negative 3 over 5. Let me settle the fractions first. So 32 is actually 2 to the power of 5. And then now my whole thing, power negative 3 over 5. Okay, so with this, let me multiply in. So this will be 2 to the power of negative 3. And this is 1 over 8. 1 over 2 cubed, which is 1 over 8. Right, for C, we have a 100 to the power of 1.5. So what does this mean is I can write this as 100 to the power of 3 over 2. So with this, 100 is 10 square, right? And the whole thing would be power 3 over 2. So when we multiply, I get 10 to the power of 3, and this is actually 1000. Okay, very long journey for C. And for part D, we have 4 to the power of 2.5 plus 27 to the power of 4 over 3. Now it is a sum. So 4 to the power of 2.5, I can write this as 2 square, right? And 2.5 simply means 5 over 2. Plus 27, I'm going to write this as 3 cubed, so we need to be familiar, yeah? Right, and converting to the base, right? So we have 3 power 4, 3. So over here we have 2 to the power of 5 plus 3 to the power of 4. 2 to the power of 5 is 32. 3 to the power of 4 would be 3, 9, 27, 81. So 32 plus 81 would give me 113. Okay, so there we go. Number 2, simplify each of the following, express your answer in index form. So question 2a, right, we have this, okay, now we are simplifying, yeah, so 3a to the power of n. Okay, so first we have a to the power of n on the inside, and I'm going to code this with power 1/3, convert the root into a power. And after this, let me combine them to a to the power of n over 3. Okay, next for part B, right, we have over here 1 over 5th root of x square. Right, so before that happens, let me write down the index for that. So 1 over x to the power of 5 over 2. Right, and in order to get my fraction up, so I would need to take 5 to the power of 5, so x to the power of 5 over 2, right? And I would need to insert a negative over there because it is a fraction. Okay, so this is to evaluate and simplify these things. Okay, alright, so we are going to start with practice now 12, and practice now 12 we are going to make use of all the laws of indices together with the rational fraction. So you're going to see a lot of rational numbers over here. So 1a, we have m squared whole thing power 5 over 6 times m power 1/3. So what happened over here is we need to settle this part over here to get m, multiply together to get m to the power of 5 over 3, and we plus 1 over 3 because law of indices, we can same base, add the fractions up, add the powers up together. So add together we have a 2, so we have answer m squared. B, part B, we can convert this root into a fraction, power 1 over 5, and we can convert this cube root into power 2 over 3 over here. Right, we have a square there, so the fraction will be 2 on top, then root will be below, right? 2 over 3. So with this, we have our 1 over 5 minus 2 over 3 because it's divide to get a negative 7 over 15. And we want positive index form, means our power must be a positive number. Now it is a negative number over here. What do we do? How to get rid of this negative number? We need to convert it and use the definition of negative indices. So negative power means send it downstairs. So 1 over m to the power of 7 over 15, positive index. Okay, so this is part B. Part C, we have a bracket over there and a power outside. What can we do? We can put in the bracket, distribute the power into the bracket. So negative 3 and this will give me 1, right? And 5 and this will give me negative 5 over 3 over here. Okay, and with this we have our m over n to the power of 5 over 3. My negative has already taken effect, so it just now become a positive 5 over 3. Okay, part D, same thing, everything inside, but we have a power negative or 1/3 on the outside. Okay, so what do? I will need to settle my y cube and also a y power negative 12 first, right? So technically speaking, I can cancel them out, so I have a y power 9 below over here. So next, what do we do? Okay, so next what do we do is I will need to settle the negative. I think make my life easier first by settling negative. Remember back then when we had a special result, okay, when we use a negative index, right, we just swap the numerator and denominator. So now negative in place, we have 10 power 3, y power 9, x power 9. So it is now time to distribute my powers into the bracket. So I have 10 power 1, y to the power of 3, x to the power of 3, right? And we don't need to put 10 power 1. And every power is a positive power. Right, part E. We have this thing over here, and we have a complicated denominator. So I'm going to leave the top alone first. Alright, and I'm going to settle the denominator. So I'm going to have h to the power of negative 4. Let's do this carefully. K to the power of positive 2 over 3. And with this, right, I have my h. Let me do my law of indices. With my negative 1/3 minus the bottom negative 4. And I have my k, negative 1 over 4 minus 2 over 3. So over here, my h, right, minus 1/3 plus 4. So I have h to the power of 11 over 3. K, I have my power negative 11 over 12. So the negative power will go down, so h to the power 11 over 3. And last but not least, I have a k to the power of 11 over 12 at the bottom, like that. Okay? Alright. Part F. For part F, we are going to look at this two different things. We have 25p squared, q power 4, half on the outside, and we are going to have p cubed, q negative 2 over 5 times, and then we have a square outside. Alright, so when we talk about, okay, let us expand our powers into this thing first, right? So first, half actually means a square root. So what is the square root of 25? 5. We have p power 1, and we have a q to the power of negative 2. Right? Can you see the effects? And on the right term, we have p to the power of 6, and we have q to the power of negative 4 over 5. Okay, so with this, let us combine our powers. We have 5p7 q to the power of negative 2.8, or I can put this as 14 over 5, right? So with this, we have our numerator 5p over 7 with a q to the power of negative 14 over 5, but the negative now become the denominator. So now I'm left with my positive index form. Okay, let us push a bit further to check on equations involving indices, and let's take a look at how to solve them. Okay, alright, come let us go on to the next part over there. Alright, so we have our practice now 13 in the same page. Same page was 72. Alright, practice now 13, page 72. Alright, so let us solve. Right, so we have two strategies over here when we want to solve an equation involving index. We normally want to look for same base, then we compare the power, or we normally look for the same power and we compare the base. Right, over here. So here 1a, we have 5 to the power of x is equals to 1, 2, 5. So without further ado, we can recognize that 125 is actually 5 to the power of 3. And we can actually compare index. Okay, comparing the index of 5, x is equals to 3. Right, so this is 1a. 1b, I'm going to have a 7x is equals to 1 over 49. So 7x is just 7x. 1 over 49 is 7 square, and it's at the denominator. So it will be 7 to the power of negative 2. Right? Negative because it's at the denominator, 2 because it's 7 square. So comparing indices, okay, or comparing my index, x equals to negative 2. Part C, 8 to the power of x is equals to 16. Now 8 and 16, they are not bases of each other. However, they share common base. So do they share 4 as the common base? No, they actually share 2 as the common base. So 8x, 8 is actually 2 to the power of 3. And we have the x there. And 16 is actually 2 to the power of 4. So comparing index. Now we can compare index because the base are the same. Okay, so 3x is equals to 4. X is equals to 4 over 3. And the last question of the day is to make use of this one over here. We have 9 to the power of negative 2 times 3k is equals to 1. So 9 itself is 3 to the power of 2 power negative 2 times, okay, let me put a dot to times. Usually I don't dot. Yeah, and then but to differentiate between this and x, I rather dot. Okay, so this one is equals to 3 to the power of something. We want to make the base the same. However, based on the definition, anything to the power of 0 is 1. So this would be 3 to the power of 0. So without further ado, I have 3 negative 4 plus k equals to 3 power 0. So what we can do is we can compare indices. Okay, indices. So negative 4 plus k equals to 0. K is equals to 4. And so this ends our video on solving equations with index, and at the same time to do rational indices. So that's all. Have a nice day.